In this video, I'd like to apply what we've learned about rational equations to the more general topic of solving an equation for a given variable. First, let's recall some fundamental rules of solving equations. The first one is that we keep equations balanced by performing the same operations on both sides. If I add 2 to one side of the equation, I have to add 2 to the other side. If I divide one side of the equation by 3, I have to divide the other side by 3 to keep it balanced. The second rule is more of a strategy for solving, or the goal of solving equations. We undo equations by performing inverse or opposite operations in order to isolate a particular variable and solve the equation. Let's look at two specific examples. Both of them are rational equations in this case. So I have one equation given here. There's several different variables. I want to solve for y, which means I want to isolate y. This is a rational equation because I have this denominator of x minus 3, and I'm going to go ahead and multiply by the LCD in order to clear the fractions. So I'm going to multiply both sides by x minus 3. And when I do that, I'll have x minus 3 times m on one side. On the other side, I'll have y minus 2 over x minus 3 times x minus 3. But guess what? Multiplying by the LCD just divides the denominator here. And so I have this equation, x minus 3 times m equals y minus 2. Just by doing that, I've made progress, right? We're a lot closer to isolating this equation for y, or solving for y. I'm going to go ahead and multiply this out. So this would be x times m minus 3 times m equals y minus 2. I'm getting closer to solving for y. I need to add 2 to both sides. This is the idea of performing an inverse operation, right? 2 is being subtracted here, so I'm going to add it to both sides. So plus 2, and I end with this, x m minus 3m plus 2. None of these can be combined because they are not like terms, so they all have to be written in my equation equals y. And that's it. I have taken this equation and I've solved for y. These other variables are still mixed in as part of my answer, but solving for a specific variable means isolating that variable in the equation. For the second example, I want to solve this equation for x. Again, that means I need to isolate x and have everything else on the other side of the equation. Well, because it's a rational equation, once again, I might start by multiplying by the LCD, the least common denominator. The LCD here is 3xy. That is the smallest thing that all of the denominators multiply into. So I'm going to multiply by 3xy. Let's think about what it looks like for each of these fractions. So 2 over x plus 3x times 3xy plus 1 over 3 times 3xy equals 1 over y times 3xy. Now there's some division here, right? This denominator of x divides with this factor of x, and I get 6y as a result. This denominator of 3 divides with this factor of 3 in the numerator, and I get xy. And this denominator of y divides with this factor of y, and I get 3x. All right, after multiplying by the LCD, there are no fractions left in my equation. I'm trying to solve for x, so I need to isolate x. I still see it in 2 places here, so I should rearrange terms to get both of these terms with x on the same side of the equation at least. I'll do that by subtracting xy. And I get this, 6y equals 3x minus xy. Now, I still have x in 2 places here. If I'm going to isolate y, I need to get it into one place. So how do I do that? Well, I can factor out the common factor of x on the right side of this equation. If I do this, I get 6y equals x, parentheses 3 minus y. So I'm factoring it out. This is the reverse of multiplying it in. And once I have this, think about the operation that's happening here. This is multiplication in between the x and the 3 minus y part. So to undo that, the inverse of that would be to divide both sides by 3 minus y. Then we get this, 6y equal over 3 minus y equals x. I have solved this rational equation for x.